Hi everyone, I hope you're well. You have a test tomorrow in Algebra 1. So I picked a few of the review questions from the homework today and I'm going to go over them so you can kind of see what they're like. You should expect some of these questions to be on the test tomorrow, so make sure it makes sense to you as we're going over it. Okay? First off, I want to apologize. I accidentally posted the long wrong version of the review. So there was a version that was 35 questions. I had cut it down to I think 12 questions, which is what I wanted you to do. But the wrong version of the review got posted on Pearson. So I know some of you guys worked through all 35 questions, which is awesome, and really struggled with some of them. Know that I know at least like the last 10 questions, I think it was, on the review, you will not see on the test tomorrow. So there were questions about regression lines and writing a quadratic from a table. You don't have to be able to do that. I apologize for those of you that spent a really long time on that review section. I didn't mean for that to get posted. So if you haven't done the review and you're going to do it, be sure that the version you have has 12 questions. It's called Review Copy 2. And somehow it didn't get posted. So here, let's get started on these. So you'll have some questions similar to some of these tomorrow. Sure you get how to do it. How does the value of a in the function affect its graph when compared to the graph of the quadratic parent function? G of x is 12x squared. So what we're trying to say is, how does this 12 affect the graph compared to the parent function? Select all that apply. Well, that 12, since that number is greater than 1, makes it narrower, and this graph is going to open upward, right? So it's narrower and opens upward. For this one, we have a negative 0.68, so now this a value is between 0 and negative 1. That's going to make this graph wider because that a is between those values. And because that a is negative, it's going to open downward. Okay? Here, state the vertex and axis of symmetry. Well, this graph has been shifted down 19. That's the only transformation that's happened. So we'd say the vertex is 0, negative 19. So from it started at 0, 0, it went down 19, so now it's 0, negative 19. The axis of symmetry is x equals, and it's going to go through the x value of the vertex, so x equals 0. Since that's 0, that's 0. Be sure to write x equals 0. If you were to just write 0 on the test, you would get it marked wrong, so be careful about that. All right, state the vertex, axis of symmetry, and which way the graph opens. So the vertex, this graph went right 4, down 4, so it would be 4, 4. Axis of symmetry, x equals whatever the x value of the vertex is, so x equals 4. And then since it's positive out front of that parenthesis, it's going to open up, right? All right, sketch the graph and the axis of symmetry. So really big thing here, it says sketch the graph and the axis of symmetry. When I went through and did this as like a practice, I did this and I kept getting marked wrong and I couldn't figure out why I was getting it wrong. It's because I didn't read the directions and I didn't read that it says to graph the quadratic and the axis of symmetry. So I just kept graphing the quadratic, and that's because I didn't read the directions. So be careful tomorrow. It's going to ask you the same thing. It's going to ask you to graph the quadratic and the axis of symmetry. Be sure to do both, okay? So this graph has a vertical dilation of 2. It's been reflected over the x-axis. It goes left 6 and up 4. So let's just write that out. It's reflected over the x-axis, vertical dilation of 2, left 6, up 4, right? So we're going to go left 6, up 4. Plot our vertex. Then it has a vertical dilation of 2. So from here, I'm going over 1, down 2. You really just have to plot those 2 points, and the graph makes it for you, right? So you kind of have a graph of a quadratic that looks like this. Like I said before, we can't forget to graph the axis of symmetry. So you then have to graph a separate line that's this vertical line that goes up and down. Okay? State the y-intercept. The y-intercept is this value. So 0, negative 0.4. Pay attention to whatever sign is in front of that. Write it in standard form. Standard form looks like this. So to get this in standard form, I need to multiply this all out. To do that, I'm going to write 0.2, x minus 3, x minus 3, minus 0.6, right? I have to start by foiling here. So I get x squared minus 3x plus 9, okay? Now I'm going to distribute this 0.2 through to everything. So I get 0.2x squared sorry, 0.2 times 3 minus 0.6 minus 0.6x, sorry, minus 0.6x, then 0.2 times 9 plus 1.8 minus 0.6, right? We're going to combine like terms, and I get 0.2x squared minus 1.2x plus 1.2. Okay, so that's our equation from vertex form to standard form. All right, use a quadratic function to model the area of a graph. We're supposed to state the function, okay? So when we state area, area is length times width. So the area of this is going to be 2x plus 6, that's the length, times the width, x plus 2. Now, just like up above, we need to start by foiling. So I'm going to have 2x squared plus 4x plus 6x plus 12. And then I can combine these to get 2x squared plus 10x plus 12. Right? That's my quadratic function. Next, I'm supposed to graph it. Well, if I want to graph this, this isn't the best form to have this in. Best form to have it in is vertex form, or at least I need to identify what the vertex is, right? So to figure out the vertex, we're going to do x equals negative b over 2a, so negative 10 over 2 times 2, right? So that's negative 10 over 4, so negative 2.5. So the x value of our vertex is negative 2.5. Now I'm going to plug that in to this equation here. So f of x equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 12, right? So I have to plug that whole thing in my calculator. And when I plug that whole thing in my calculator, I get negative 0.5. Okay, so my vertex is negative 2.5, negative 0.5. Okay, so we can plot that point to estimate a bit. So it's about there. It has a vertical dilation of 2, so from here I'm going over 1, up 1, 2. You guys have to kind of estimate that point right here, right? Your graph kind of looks like that. All right, then last question, we're writing the equation for this quadratic given this information. Well, luckily the equation's stated right here, right? So we just have to plug these values in. The initial vertical velocity, that's v sub 0. The initial height, that's h sub 0. So we have h of t equals negative 16t squared plus 64t plus 90. Now be sure to use the variable they give you. So since it says t in the equation, I'm using t when I write the equation here. Be sure to include t and don't do x. I know you guys are used to writing x. Then it says find the maximum height. Well, to get the max height, again, we need to do like what we did up here. So we're going to do negative b over 2a. So that's negative 64 over 2 times negative 16. So that's negative 64 over negative 32, which is 2, right? I'm going to take 2 and plug it into my equation. Write that again. H of t equals negative 16 times 2 squared plus 64 times 2 plus 90. Okay, and again, I have to plug that in my calculator. So negative 16 times 2 squared plus 64 times 2 plus 90. And I get 170. So the max height is 170 feet, right? If it asks when does it hit that max height, it hits the max height at 2 seconds. Okay? Well, hopefully this was helpful. Email me tonight or early in the morning with any questions you have before your test. I'll try to get back to you depending on what time you email me tonight. I might not respond till the morning, but good luck and talk to you soon.